Hello, welcome to Advanced Composites. Today is the fourth day of the ongoing, that is the 10th week of this course. Over last 3 days we have been discussing the role of D16 and D26 on the behavior of plates and how these terms influence the solutions which are achieved using formulations such as a special Galerkin or finite element method. And we have seen that in that context, edge effects become important characteristics which are heavily influenced because of the presence of D16 and D26, and these terms vanish when D16 and D26 are not present. Another feature is something we are going to explore today. Specifically, what we are going to see or explore is how does the value of mx or my for that sake, or for that sake even mxy, how does it change not at the edges, but also inside the plate itself. So, that is another thing we will look at today. So, role of D16 and D26 on mx, my inside the plate. So, in the last class we had developed an expression for mx, that mx equals double summation of D11 m pi over a whole square plus D12 n pi over b whole square sin m pi x over a sin n pi y over b plus 2 D16 m n pi square over a b cosine m pi x over a cosine n pi y over b. Okay. So, this is mx. Now, this relation, if you remember, was true if the coordinate system of the plate was located at the corner of the plate. So, this is my x axis, this is my y axis, and my plate is something like this. Okay, and it is simply supported on all the four sides. So, what we are going to explore is how does mx change as I move inside the plate, and how does it change and how does it get influenced by this term D16. So, to do that, probably a better choice of coordinate system would be if we have the coordinate system located at the midpoint. Okay. So, this is my new coordinate system, let us call this x bar and let us call this y bar. So, what is x bar? X bar is equal to x plus a over 2 and y bar is equal to y plus b over 2. Right, or you can say that x is equal to x bar minus a over 2 and y is equal to y bar minus b over 2. Okay. So, we do this transformation. So, all we have to do is we plug in this. So, what does sin m pi x over a? It becomes sin m pi over a into x minus a over 2, right. x I am replacing by x bar minus a by 2. So I have put x bar. So I am sorry. So this is x minus a by 2 minus b by 2 and minus a over 2. So this will be plus and this will be plus. Okay. And this becomes sine m pi x bar over a minus m pi a over 2 a. So a goes away, right. So anyway, so you can do all this and you can simplify it further, and essentially what you will end up with something like this: sine m pi x bar over a minus pi over 2. So from here to here, so okay, so here to here, if I have to make that jump, I have to make one additional, that this will be called big M, and this big M is only odd. It is only going to be odd. Similarly, I have the same transformation for sine n pi x over a. It gets transformed to sine n pi x bar over a minus pi over 2. I am sorry, yeah. And here n is odd. Okay. And the same thing can be applied to cosine. So if I shift my coordinate system to the center, relationship for mx, it becomes d11 m pi over b, excuse me, m pi over a whole square plus d12 n pi over b whole square sine m pi x over a, excuse me, yeah, minus pi over 2 sine n pi x over b minus pi over 2 plus 2d16 m n pi square over a b cosine m pi x over a. Oh, so this should be plus. Pi over 2 cosine n pi x bar over, excuse me, so I have made a mistake here, it should be y. So n pi y bar over b plus, and here also I should have y this is there. Okay. So this is the transformed relation. So let's now look at this a little more carefully, and what does it mean. So let's call this entire thing as dmn and this entire thing as cmn. So the mnth term, what is mnth term? For the mnth term, what will we have? We will have dmn sine m pi x bar over a plus pi over 2 sin n pi y bar over b plus pi over 2 plus c mn cosine this times cosine this. And what is, yeah, so what is sin m pi x plus pi by 2? What is sin theta plus pi by 2? It is sin theta plus pi by 2. So you have sin, you have theta, and then you have, so it is cosine theta. So this is cosine, and I can remove pi over 2 from here, and same thing here, and this is sine, and negative negative gets multiplied, so it becomes, okay. So pi has gone. Okay. Now let us look at the plate geometry again. So our plate geometry is this. The origin is now at the center. Okay. Consider a point, or let us, for purposes of convention, just for this lecture only, so this is x bar and this is y bar. Okay. So consider a point x naught, y naught, and consider a point minus x naught minus y naught, same point but on the other side, and then the third point is, this is what, which one, minus x naught y naught, and the fourth point is x naught minus y naught. Okay. So if d16 was equal to 0 and d26, actually d26 for mx it does not matter, but if d16 and d26 were 0, then mx so if that was 0, then what would happen? This term will go away, because this is related to the d16 term, this is related to d16 term, this term will not exist. So the only term which matters is cosine term, and so and cosine, instead of x naught I put minus x naught, it does not change, instead of y naught I put minus y naught, it does not change. So what it means is that mx at x naught y naught is equal to mx at minus x naught y naught is equal to mx at x naught minus y naught is equal to mx at x naught minus y naught. Okay. Which means that mx is symmetric about, so it is symmetric. So if this is the plate, then what are the planes of symmetry? This is one plane of symmetry, this is another plane of symmetry, this is, so these are the two planes of symmetries. Okay. And this is another plane of symmetry, and this is another plane of symmetry. So this is how, if d16 and d26, so either whether the point is here or here or here or here, does not matter, the value of mx is going to be same. Now if d16 is not equal to 0, then what happens, and d26 is not equal to 0, then we also have to consider the sine term. Okay. And in that case what we find is, so if I replace x by x naught, this cosine term does not change, this cosine term does not change, but this thing becomes negative because sine of minus x is, है ना. So what that means is that m x naught y naught is, and these things are added up, right. So here something the sum will change. So this will not be equal to m minus x naught y naught. What else? M x naught y naught. Now if I change both x and y both to their negative values, then this negative and this negative will multiply. So this m x naught y naught will be same as m minus x naught minus y naught. And the last thing is m x naught y naught for the same reason will not be equal to m x naught minus y naught, and finally we can say that m x naught minus y naught will be equal to m minus x naught y naught. Okay. So these are there. So this is what happens when D16 and D26 are not 0. So in that case, if I have a plate and this is my origin, then a point here will have the same moment as a point here, and a point here will have a same moment as a point here. So the planes of symmetry in this case are, what are the planes of symmetry? See, the planes of symmetry are these. In this case we had more planes of symmetry, but here we have planes of symmetry only along the diagonals. Here we have along the diagonals as well as along the lines which are cutting through the mid of the plate on both sides. Okay. So this is something very important to understand, and because of this the plate also starts twisting, the plane also starts developing twist curvature because the moments are not symmetrically distributed around the origin. So this is another thing I wanted to share with you, and that closes our discussion on the treatment of D16 and D26. Tomorrow we will start a new topic which will be related to vibrations of these types of plates and dynamic equilibrium in these types of plates. So that closes our discussion for today, and we look forward to seeing you tomorrow. Thank you.